Good evening, students. How are you all? Okay, so till now we are doing the chapter construction. We have started this 2 classes back. So what we have done so far, we have learned the basic concepts of the construction, like how to draw the different angles, basically the multiple of 15 with the help of compass and scale. Secondly, in the last class, we have learned how to divide a given line segment in a particular ratio. Like if the line segment is of 10 centimeter, how we can divide it into the ratio of 2:3 or 4:5. In that ratio, how we can divide. Secondly, we have also learned that how we can construct an triangle which is similar to given triangle but with a different scale factor. So scale factor we have done, like what is the scale factor? It is just the ratio of the new triangle, ratio of the side of the new triangle to the original one. So we have done that question in which we are drawing a triangle which is larger to the previous triangle or smaller to the previous triangle but similar to that one. So these are the things we have covered so far. Right, Shillong? Good evening. Okay, so today our aim is to cover, we will learn today how to construct tangents to a circle. This is our aim for today. Okay, so before starting this one, let us have a look on the previous topic. I am giving you one question, do that one and then we will move ahead, right? So do this question, a very basic information. Triangle ABC, a triangle ABC is given. Let's say AB is 6 centimeter, BC is 7 centimeter and AC is 5 centimeter. The 3 dimensions of a triangle are given. Construct another triangle having scale factor of 3/2, which is similar to previous one. So triangle ABC is given and the 3 dimensions of a triangle are given. So we have to construct another triangle which is having a scale factor of 3/2 and which is similar to the given triangle. Try it, all of you. Shillong, we will cover that afterwards. Let us finish this course and then we will cover afterward what you are talking about. Because the topic which you are mentioning, Shillong, that is not a common topic. So Shillong, are you able to draw this diagram? Any difficulty in this one? We are doing chapter construction from the past two classes. The last class and the before that one also. We were doing construction. Okay, okay. Okay, I understand. No worries. So Itanagar, are you able to draw? How many students are present in Itanagar? Oh, Shillong, I am very happy that you got 96 in maths. That's great. Congratulations. Okay, okay. So draw it Itanagar, and when you are completed, just let me know. Or if you have any difficulty also, just let me know. Or if you can brought all the things, Shillong, like in 2, 3, and 5 to 10 minutes, if you can arrange the only you need the compass, scale, and pencil. If you can arrange, that would be great. So can you arrange any compass or scale right now? Yeah, no, like this is just a revision of the topic which we have done previously. If you know the justification, then you can do it after some time. I have just given you this question to do a quick revision of the topic. Have you completed? Although in exam you have to do the justification, but right now you can leave it as of now. If you have done the construction, then we can move forward. Okay then. So done, right? So Itanagar. So shall we move ahead? Okay, okay, do it, do it. Okay. So let's move ahead. So as discussed, we have to start today tangents to a circle. How we can draw tangents to a circle? Okay. So in doing the tangents, first of all, let us see what do you mean by tangent. As you all know, that tangent is a line which touches the circle at exactly one point. Yes, yes, Shillong, yes. So one line, a line which is in touching the circle at exactly one point. Like if this is one line, this is circle, and if we draw this line. So if this point, if it is touching the circle at only one point, this line will be called a tangent to the circle. So we have to learn how we can draw the construction of a tangent, and in different circumstances, like special conditions will be given in different cases how we can draw the tangents to a circle. So two important properties which we have to learn over here. First one is that angle between radius and tangent at point of contact is 90 degree. This is the property which you have learned in the chapter circle also. Like if we draw a circle and if we draw a tangent to it, then the tangent and radius makes the angle 90 degree at the point of contact. Like this angle is 90 degree. I hope all of you remember this property of the circle and tangent from the chapter 10, I guess. All of you know this property? Okay. Second property is alternate segment theorem. Anyone knows about this theorem, alternate segment theorem? Have you heard about this alternate segment theorem? What is that? What is the statement of this thing? Because we are going to use this concept in drawing the tangent. Okay, so let's learn this one. It's a quick, easy one. It says that if there is a circle and suppose this is the chord AB, right? And there is a tangent at point B. So this is the tangent. This line L is the tangent at the point of contact is B. And from B, we have drawn one chord to the circle. Now, whatever angle this chord is making with the tangent, this angle, this complete angle, let's name this one as C. So, angle ABC is the angle which is the chord is making with this tangent. So, the same angle this chord will make in the alternate segment, because segment means when we draw a chord in a circle that divides the circle into two parts. One is, those two parts are known as segment, major and minor. So this one is the one segment on the right side of this chord, and the other one is the larger segment. So this chord will make one more angle in the other segment from points A and B at the circumference of the circle, like this. Right, so whatever angle he is making, this angle and this angle, let's say it is D. So we can say angle ABC is equal to angle ADB. This chord is making an angle with the tangent in one segment. Same angle will be found by this chord in the alternate segment. This is known as alternate segment theorem. These two angles are equal. And how we can prove this one? We can prove it like this. Suppose this O is the center of the circle, and if we join this OB and OA, if we join this OB and OA, we know again OB is the radius and L is the tangent. So it means the angle between the radius and tangent is 90 degree. So if this angle is, let's say, theta, angle ABC is theta, so this remaining angle is nothing but 90 minus theta inside angle OBA, and this angle will also be 90 minus theta, angle OAB, because OB is equal to OA. We know OB is equal to OA, both are radius, so base angle will also be equal 90 minus theta and 90 minus theta. So if both angles are 90 minus theta, so in triangle AOB, angle AOB will be 180 minus 2 times of 90 minus theta. 180 minus 2 times of 90 minus theta, and when we will simplify this one, this will become 2 theta. So this central angle of the circle will be 2 theta. Right? If this central angle will be 2 theta, and we know in the 9th class you have studied that angle made at the center of a circle is double of the angle subtended in the remaining part of the circle. So if this is 2 theta, this will be theta. So we can say ABC is equal to ADB. All of you are getting this theorem? How 2 theta? See, this triangle, if I draw it here, I am drawing this triangle over here. This triangle O, so the larger view you can see. This is the OAB triangle, right? This angle is 90 minus theta, and this angle is also 90 minus theta, because OA is equal to OB, because both are the radius of a circle, so base angle will be equal. And if you subtract triangle angle sum property you will apply, you will get 2 theta. 180 would get cancelled. Getting it? How it is 2 theta? So if this central angle is 2 theta, then the angle ADB would be theta by that theorem. Inscribed angle theorem it means angle subtended at the center is double of the angle subtended in the remaining part of the circle. So now let us start with the question and see how we can use this theorem in drawing the tangent to a circle. So write the first type. construction of tangent to a circle at a given point. At a given point means the point is given on the circumference of the circle, and on that point we have to draw the tangent. In this one, again there are two cases. When center is known. When we know the, when center is known means when we have to use the center of the circle to draw the tangent, and second one would be when we don't have to use the center of the circle to draw the tangent. So, keep your compass ready. So, let us say, let us do the question itself. So, suppose there is a circle of radius 3 centimeter. Draw tangent on it at point A. Which lies on circle. So we have to draw a circle of radius 3 centimeter, and there is a point A on the circumference of the circle, and then we have to draw the tangent. So first of all of you draw a circle of radius 3 centimeter. All of you draw it. And let me know when you are done. After every step, just give me the hint that you have done. Draw a circle of radius 3 centimeter. Now, draw one radius of this circle. Let us say from this point O, just join it to the circumference. So this OA will be the radius, right? Draw the radius. Now, after drawing the radius, I have given this radius name as OA, and now you know that the at point A we have to draw the tangent, and you know that the angle between the radius and tangent at point of contact is 90 degree. So we have to do the basic type, like at point A, draw an angle of 90 degree using the compass. So all of you know how to draw 90 degree, like by taking A as the center, we have to draw one arc like this, then two arcs 60 and 120, then upward arc over here, and then we have to join it like this. So it will pass through A. Like this, this at angle at point A, we have to draw the 90 degree angle with the compass. All of you know how to do this. We have done it in the starting. So draw it. So have you drawn it, Itanagar and Shillong? Actually, this alternate segment theorem directly they will not ask because it is not mentioned in the syllabus, but the way in which we are drawing the tangent, the second case when we will draw the tangent, we will use that theorem, and this is helpful in solving the competitive examinations questions because it is very important part of aspect of geometry. Directly they will not ask that state and prove alternate segment theorem, it is not there, but it is useful in solving questions on geometry, and we will use that concept in the next part of this construction when the center is not known. So have you drawn this case? Have you drawn this tangent? Okay, draw it. Okay, so let's move ahead. So this was the part when drawing a tangent to a circle at a point on the circle when using the center. Now let us take the second case. When center is not known. The meaning of the center is not known means, but when we draw a circle we know where the center lies, but it means we don't have to use the center of the circle to draw the tangent. So the question is, so it says draw a circle of radius 4 centimeter, take a point P on it, and without using center of the circle, draw tangent to the circle. Okay. So first step, as you all know, we have to draw the circle having radius 4 centimeter. So let us draw. So all of you draw the circle of radius 4 centimeter. All of you draw it. Okay. Now take any point P. So let us say I am taking point over here. This is point P. So take point P on a circle. You can take anywhere. I have taken it over here. And now just remember that we don't have to use the center of the circle while drawing tangent. So in this case, we will use that alternate segment theorem. Now let's see how it works. So after taking point P, draw any chord. So let us say with the help of scale, I have drawn chord this. Chord PQ. Draw any chord of any line. From this point P, you can draw any chord. After drawing this chord PQ, make an angle with the end points are P and Q on the circle. So angle means like this. Join this P to some angle over here and this to this. Any random. Just with the help of scale, draw complete one triangle. You can draw any type of triangle. Make sure one vertex should lie on the circle. So let's say name this one as R. From PQ, draw this one. Do it till now. Okay. Now you know, if you remember that alternate segment theorem, if we go through it once again, it was like angle ADB. This was the angle ADB, which is framing, which is we can see in the circle. Angle ADB was equal to angle ABC. So what we have to draw, or what we have to do, whatever angle we have drawn in the circle, equal to that angle, we have to draw another angle. So So with the help of compass, angle QRP. So this is the angle QRP. We don't know what is the measure, but whatever the measure of this angle, with equal measure of QRP, we have to draw another angle which is QP and some line which is extending this one. So how you can draw this? Open your compass, keep the needle of the compass on point R and cut an arc like this. By taking R as center, draw an arc like this, and with the same compass measurement, by taking P as center, we have to draw an arc like this with the same angular measurement. First of all, from point R, draw an arc, and with the same angular measurement, with P as center, draw one arc like this. Do it. Okay. Now, suppose the R, from the point R, whatever arc you have drawn, let us say this is intersecting at A and B. So, open your compass according to the length of AB. Whatever is the length of this AB, open your compass according to the length of AB, and by keeping or by taking C, this point as the center, draw an arc like this, which will cut this arc. Whatever is the length of AB, open your compass, keep your needle on point A, pencil on point B, whatever is the length of AB. Now by taking C as center, cut an arc like this on this given arc. So you will get, let's say this point is D. Okay. Now from this point P and D, draw a line passing through P and D. With the help of a scale, draw a line like this, passing through P and D. So this will be your required tangent. From P and D, draw a line. And you will see that this line will touch the circle at only one point, which is P. You can write the steps of construction also, because in the 9th class also you have done. So steps of construction, like if they are asking in the question, write the steps of construction, so you can mention like draw a circle, draw an chord, draw an angle PRQ, whatever we are doing, you can write it. All of you have done this steps of construction in the 9th class, right? You know how to write the steps of construction in any question. If they are asking, you can mention. So is this clear to all of you? What we have done? We have done two things. How to draw a tangent to a circle at a given point on it. First one, when center is not known, center is known, this case. And second case, when center is not known. Is this clear to all of you? Any difficulty in this one? Okay. Now, second part is the second type. Construction of tangent from a point, or you can say from an external point. Construction of a tangent from an external point. So previously we have done when the point was lying on the circle. Right now we are doing when the point is away from outside the circle. But as you know that from inside the circle we cannot draw the tangent. Tangent can be drawn either from on the circle and outside the circle. And you know the two things you already know, that suppose if there is a point A over here, so we can draw how many tangents we can draw? We can draw two tangents. One is like this and second one is like this. These are the tangents we can draw. Suppose AP and AQ. And we also know that length of tangent drawn from an external point to a circle are equal. Right? This is the thing which we have done in the chapter circle. Length of tangent from an external point is equal, and we can draw two tangents to a circle from an external point, and these are known as pair of tangents. Okay, this one you know. So let us start. Okay, where do we apply the concept of tangent in our daily life? See, every person's life is different. It's not mandatory that everyone is using the tangent. Like I am using the concept of tangent every day in my life, but maybe you are not using. It is just like it depends on the condition. Like if we are calculating something, like if we are, let's say, you have a circular plot and we have to draw the shortest path. So in that case, like suppose this is the garden, and it is exactly in the form of circle, right? And there is a point over here, okay? And someone says that you are standing at the center, and effectively it not happens that someone is asking the mathematical question with your daily life, but this is the concept where we can use. Suppose we have to apply like at what point at what distance this point should lie from the circle. So if you draw this part, this tangent, so this triangle you can apply and you can draw the right angle triangle. So if the radius is known and the distance from the center is known, and then they will ask you to what is the distance from the end point of the circle. So you can means the end point of the circle is the tangent from where the line is touching. Or since right now you are in 10th class, when you will go to the 11th class, you will understand there is a term called differentiation. If you opt for mathematics in 11th class, so there is a term called differentiation. Differentiation is finding the tangent at point. Tangent gives us the slope, or like in the coordinate geometry we were doing this thing, slope. I hope you have learned slope in the physics also, rise over run. So tangent gives us what is the inclination in mathematical way. If we can say tangent gives us at what point something is inclined, like what is the angle of inclination. With the help of tangent we can find. So these are the detailed application of tangent. In the 10th class you are not required to do these, but when you will go to the 11th class, then you will understand the concept of this one very deeply, like in mathematically how we can use this one. Got it? And frankly speaking, no one asks you the questions related to tangent in your daily life, like you are standing at some point and no one is going to ask you like what is the tangent from this point to that point, or no one will ask you calculate the height of this one using Pythagoras theorem. In everyday life we don't use these terms unless you are surrounded by mathematicians. Getting it? Is this clear? Like nobody is going to ask you these types of questions everyday life. Nobody asks you. Okay, so let's take a break over here. So after the break we will cover that topic. We will start this one, construction of tangent from an external point. This we will cover after the break. So let's take a break, and after the break we will resume from this one. Okay, welcome back students. So let us continue with this one. So we are doing construction of tangent from an external point. Sisipur, this question which you have asked, can you send it on the WhatsApp group so that every other person can also see? Okay, so construction of a tangent from an external point. So let us start with the question. Question 1 says, draw a circle of radius 3 centimeter. Take a point at a distance of 5.5 centimeter from center of circle. So from the center of the circle, we have to take a point at a distance of 5.5 centimeter. Radius of the circle is 3. From P, draw two tangents at circle. This is the question. So now, as the question says, draw a circle of radius 3 centimeter. So first of all, we will draw the circle of radius 3 centimeter. And we are doing this one, construction of tangent from an external point. Write one point over here when center is known. Again, there are two cases, when center is known and when the center is not known. So in this case, we are taking help of the center to draw the diagram. So draw this circle of radius 3 centimeter. All of you have drawn? CC4, Itanagar, Shillong. Draw the circle of radius 3 centimeter. Okay. Now, after this, we know the second step says, take a point P at a distance of 5.5 centimeter from center of a circle. So from this center, with the help of scale, draw a line which is, or take a point P which is at a distance of 5.5 centimeter. So let's say this point P is over here. Let's say name, center of the circle is O. And see, this construction what we are drawing, like taking a point P outside the circle at a distance of 5.5 centimeter, do it with a dashed line. Why we differentiate between dashed and this one? So that since we are drawing the tangent, so if we draw the tangent with the continuous line, the solid line, it is like it looks different from the other one. So it is easy to identify which one is the final diagram and which one we have used to draw it. So that's why we are drawing it with the dashed line. So all of you have drawn point P, distance OP is 5.5. Oh, it's easy for, that's great. Okay, so after taking point P, what we have to draw? By taking OP as a diameter, we have to draw another circle. So how we will draw a circle by taking OP as diameter? So first of all, we have to find what is the center of this OP. Now to get the center of OP, we have to draw the perpendicular bisector of OP. And you know how to draw the perpendicular bisector? Open your compass more than half of the length of OP. By taking P as center, we have to draw one arc over here and one is on the bottom. And then by taking O as center, we have to draw another arc which will intersect these arcs. And then we will join it. So this gives us the perpendicular bisector of OP, and at whatever point it is intersecting, let's say this point is Q. So this Q point is the midpoint of OP. Do it till now. All of you have drawn? Do it. Okay. Now you know that Q is the midpoint of OP. Now taking Q as center and OP or OQ as radius, we have to draw another circle. By taking Q as center, we have to draw a circle like this. By taking Q as center, draw a circle and radius is OQ. So that circle will pass through point O and P, which will act as a diametric ends of the circle. Yeah, it's look like roti. See, I am drawing it with my free hand with this pen. You have the compass, and there is not a option of drawing in this one. Let me see. I don't have any option of drawing a circle like we have in the paint option. So I have to draw it with the free hand. Yeah, it looks like. There are app for geometry also, but right now on this platform which we are using, I don't have any option for creating like square, rectangle, straight line, circle, the shapes. That's why I have to draw it with the free hand. Okay, so all of you have drawn till now? Itanagar, Shillong, Sisipur, you have already drawn this one. Okay, now you can see the larger circle is intersecting the smaller circle at 2 points. Name this one as, let's say, T and R. So the point of intersection. Now with the help of scale, join the point PT and PR. So with the help of a scale, when you will join it, like this and like this. So join PT and PR. So PT and PR are tangents. All of you have drawn? Okay, any difficulty in this one? So what we are doing? Draw one circle, take a point outside the circle and draw another circle by taking OPS diameter, and then point of intersection we have to join it from the P. Okay, so let's do another type of question when again we have to use the center. Suppose it says draw a pair of tangents to a circle of radius 4 centimeter, which are inclined to each other at an angle of 60 degree. Now what do we mean by this? The tangents are inclined to each other at an angle 60 degree. It means from whatever point we are drawing the tangent, both the tangent makes an angle of 60 degree, like this. Like if we draw a rough diagram, suppose this is a circle and I am taking a point over here. So when we are drawing this tangents like this, okay, so the angle between them, this angle is 60 degree. This is the meaning that tangents are inclined at an angle of 60 degree. Understood the meaning of the question? Are you getting the meaning of the question? Like what does it mean? We have to draw tangents from a point which are inclined at an angle of 60 degree. Now, what we have to do, if we see in the rough diagram, since we can use the center, this is the center. Suppose the point PR and PQ are the point of tangents. If you join from the center, so this ORPQ is a quadrilateral, and we know the angle between the tangent and the radius at point of contact is 90 degree. So this angle is 90 degree and this angle is 90 degree. We already know this thing. So we can find this angle, angle ROQ. So you know angle P plus angle Q plus angle R, PQR plus angle O is 360. So angle P has to be 60, this Q is 90, R is 90, we have to find angle O. So angle O needs to be 120 degree. Right? With some calculation we can find what is the angle at the center. Angle ROQ has to be 120 degree. All of you are getting it? Is this clear to all of you? Like how I have calculated the central angle ROQ? Because angle between the radius and the tangent is 90 degree, we all know. That angle P is given 60 degrees. So by applying the angle sum property of quadrilateral, we can find the remaining last angle. Now in order to draw it, how we can draw? Now we know the rough diagram. So first, 360. Oh, sorry. Here I have written by mistake. This needs to be 360, sorry. This is 360. When we will solve this one and we will get it. This was 360, I have written it. Okay? Is this clear now? Now we know the complete part, how we can draw. Just draw a circle like this. Take a point O. We just have to draw the angle, that's it. Draw any radius. Let's say I am drawing this radius. Now, on this point O, we know the central angle is 120 degree. So we have to draw 120 degree on this point O. So if I draw 120 degree on point O with the help of compass, I have to draw it like this, and these two arc. And if I join it, it will be 120 degree. Let's say this is T and R. 120 degree I have drawn in the center. Right? And after this, you know, on point R and Q, those 2 points at the end of radius, we have to draw 90 degree. So you can draw 90 degree over here. And all of you know how to draw 90 degree. So draw 90 degree like this. And similarly 90 degree over here also. So when you draw this 90 degree, they will intersect at some point. So this point will be P and this angle would be 60 degree. So only what we have to draw central angle 120 degree we can draw after drawing one radius, and at end of both radius draw 90 degree angle. They will intersect at some point. That point will be P. Do it. Okay, that's great, CC4. Now measure with the help of protractor also that this angle P should be 60 degree also. Are you getting it? That's great, perfect. Itanagar? Okay, that's great. And Itanagar, measure it with the help of compass also. Angle P, because angle P should be 60 degree. Are you getting it? And see, some deviation is acceptable, like it should be 60 degrees. Suppose you are getting 59 or 61. Up to 2 degree it is acceptable. But make sure it should not be 2 degree, more than 2 degree. Like if the required angle has to be 60 and you are getting answer as 65, that is not acceptable. So are you getting it? Okay, that's great. So what we have done so far in this one, when we are drawing a tangent from an external point, again there are two cases in this one. When the center is known, or basically when we have to use the center and we don't have to use the center. So when we have to use the center, we have drawn this question and the second question. Now there is the second aspect of this one is when we have to draw the tangent from an external point without using the center of the circle. Right, this is one aspect that we will cover in the next class. Okay, so is it clear to all what we have done so far today? We have learned 4 things. Like first was the revision, second one is the drawing tangent from the point on the circle with center, without center, and the fourth one from an external point using center. Is this clear to all of you till now? Itanagar, CC4. Okay, that's great. So in the next class also bring your complete geometry box and we will cover that part. And then our syllabus is now over. In the next class it will get over. And from after those classes we will start the revision. So make sure you come up with your doubts also, and on the WhatsApp group you can tell me like this is the question, or whatever question you are having difficulty you can send on the WhatsApp, or you can tell me the name of the chapter also which you want to do the revision, right? So after the next class, from the third class we will start the revision. Is this clear to all of you? Okay then, that's all for today. We will meet in the next class. Bye.